All right, statistics. We're looking at data classification today, how we classify data that we gather. Okay, so first thing I want to show you, we've got some problems we're going to do here. This says name each level of measurement for which data can be qualitative. Okay, so we got to select which one can be qualitative. All right, let me take you over to this. Here's my computer screen, and you can see on here, well, shoot, what happened to it? Okay, let me get it back on here. Lost it. Okay, when you go to this computer screen, here's this problem we're doing, okay? If you look up in this top right corner, we see this question help. All right, if you click on that question help, let me get my thing up here. It is, okay? When you click on this question help, this little menu pops up. Help me solve this. If you click on that, the computer will help you solve the problem. You can watch a video. Now, some problems don't have all these options, and some have maybe others. But here's once you see the textbook. I think every one of these questions has a textbook where if you click on that, it shows you the textbook. It comes on the screen here. So and it takes you right to the page that's pertinent to what you're doing on this question. So let me get it on here. Okay, here it comes. All right, here you go. You can see the book right here, data classification. And so we see here a definition, qualitative data versus quantitative data. Qualitative attributes labels or non-numerical entries. Qualitative, the root word of that is quality. Like, people have certain qualities about them. Like a person might have blonde hair, a person might have blue eyes, different qualities. And this is data that has like qualities about it. But quantitative data, see, this is quantitative right here. Quantitative, the root word of that is quantity, which quantity is like a value. And this consists of numbers and measurements, it says, okay? But we got to know the difference between quality and quantity. Quality is like a quality somebody has, some kind of label or attribute, where a quantity is some kind of value. Okay? All right, and I think here we got an example here. Okay, so classify by type here. So if you look at this table here, we have this on the left, we have sports. So these right here are just qualitative because these are qualities, whether you're playing basketball, baseball, or football, these are qualities. Over here, the number of head entries, this is quantitative. So we see qualitative and quantitative. Now, numbers are not necessarily quantitative. There might be numbers that are qualitative. And we'll look at something like that in a minute. Right here in the next page, click on the next page. Here's definitions. Keep getting my fingers in the way. We have nominal level of measurement and ordinal level of measurement. Now, when you're talking about qualitative data, qualitative can be these two ways. Nominal, which means it's just like some kind of name. Nominal means like it's a name. It's categorized as a name or a label. And look what it says here. No mathematical computations can be made at that level. In fact, a lot of times this nominal level is not even numbers. Then you have ordinal level of measurement that can be qualitative. This can be qualitative or quantitative. Data at this level can be arranged in order or ranked, but differences between the data entries are not meaningful. Let's see if there's an example down here. if you look at this right here, the top 5 U.S. occupations with the most job. Okay, these are ranked 1 through 5. So these are qualitative because these are qualities here: personal care aides, registered nurses, home health aides, but they're arranged in order. So that would be ordinal. See here? That would be ordinal because they're arranged in order. So that'd be ordinal. Okay? Now, over here, this is just nominal. So you've got action, adventure, comedy. These are not arranged in any order, so that's just nominal. Okay, but these are both qualitative because they both have qualities about them. These are in order though, which makes them ordinal, and these, there's really no way to put them in order. They're just in alphabetical order maybe, but there's no really order about them, so that's just nominal. Okay. All right, then we have interval and ratio level. Interval can be ordered, and meaningful differences can be calculated. So you can calculate differences between the values of stuff. Okay. Then we have this next one, which is ratio, which is you can have differences there, but a ratio also has where you can express one as a multiple of another, it says. And then one more thing we see on here, an inherent zero. An inherent zero is a zero that implies none. For instance, the amount of money you may have in a savings account, that could be $0, which means you have none. So that represents no money. Okay. On the other hand, a temperature of 0 degrees Celsius does not represent a condition in which no heat is present. So just because it's 0 degrees, that doesn't mean there's no heat. There is some heat present, but just not much. So that's not really a inherent zero. If you look at this down here, being in the interval level versus being the ratio level, think of like twice as much. What the meaning of twice as much? Like for instance, $2 is twice as much as $1. So these data are ratio level. Okay, let me go to this last page here. This might make it have a lot more sense. If you look at this table right here, and you might pull this table up, you know, to maybe write this down or maybe take a picture of it on your phone. This shows the 4 levels of measurement: nominal, ordinal, interval, ratio. NOIR, no ear. NOIR, no ear. They all involve putting data in categories. Okay, and if you notice, this is a no, and these are all yes. Arranging in order, nominal, you cannot arrange in order, but the other ones you can. And then subtracting data entries, you can't do nominal, ordinal, but now interval and ratio you can. But then the last one here, determine that one entry is a multiple of another. Ratio is the only one that does that. So you can see how this table works. Okay, let me scroll this up and look at this here. This kind of explains the 4 kinds a little bit. Okay, let me get it right to there. Okay, and there's some examples here, like nominal. Here's an example of types of shows televised by networks. He just has all the shows, and they can't be put in order because what's the order? They're in alphabetical order maybe, but well, actually they're not in alphabetical order. But that's nominal. You can put in a category. Okay, ordinal. Okay, here we got motion pictures, and look, we got general. We got PG, PG-13, R, and then NC-17. These are in order. See how there's an order to them? See the general, anybody can go that, but they get more restricted as you go on. So they're in categories that are ordered. So PG rating has a stronger restriction than a G rating. So there's stronger restrictions the more you go down. All right, if you look at the interval level, okay, on the interval level, okay, we've got average monthly temperatures in Denver, Colorado. So you see January, February, March, you see the temperatures involved. Okay, so these are categories again, and you can put them in order as far as what the months and stuff, or you can put them in order as far as how much rain you had. But the difference here is you can subtract them. For instance, like this says over here, you can subtract these two numbers right here. You can tell that August is 9 degrees warmer than September. So you can subtract them to get information. So that's what you do for interval level. You can subtract them for certain reasons. And then down here, ratio. Ratio here, you have the average monthly precipitation. Okay, so you can see the precipitation in all the different months. Okay, this is these can be put in categories, but here you can subtract them to see that. All right, February is just 3/100ths of an inch more than January, so they're really close. So you can subtract them and get information, but you also can divide them, like here, to see that that this one's twice as much as that one. If you would divide them, you can see this. So there's about twice as much precipitation in June as it is in March. All right, so this may be a little hard to understand at first. You might have to review it and think about it and stuff. But I think once you do some of the homework problems, it won't be too bad. So that's what I'm going to do. I'm going to go over here and we'll look at some of these homework problems. Okay? So if you look at number 1, name each level of measurement for which the data can be qualitative. Qualitative, that means it has a quality about it. Okay, remember there's only 2 of those. And that's ordinal and nominal. Remember, they go in N-O-I-R. That's the order they go. So this is nominal, ordinal, interval, and ratio. That's the order they go. All right, these 2 right here, those are qualitative. Okay, these 3 right here are quantitative. Okay, ordinal can be either one. Okay, but that's what we have there. Okay, now number 2, name these which could be quantitative. Quantitative, well, that's these 3 here: ordinal, interval. So that's going to be ordinal, interval, and ratio. Those 3 are here. Of course, here's the answer right there. There's the answer. Okay. Number 3, determine whether the statement is true or false. If false, rewrite it as a true statement. All right, data at the ordinal level are quantitative only. Okay, now we just said it right here. Ordinal level can be both. So that's false. This is false. Now, is it false because of this or is it false because of that? Well, it's false. Then it says data at the ordinal level can be qualitative or quantitative. It's this one right here. So there's the answer A. You can see it here. Here's the answer A. Okay. Let's see here. Let's skip down to number 5. Determine whether the statement is true or false. If false, rewrite it as a true statement. All right, so more types of calculations can be performed with data at the nominal level than with data at the interval level. Okay, now remember this goes in order. So like the further down you go, the more calculations you can do. Okay, so this is comparing, it says nominal and interval. All right, well, nominal, you can't do any calculations. So the interval level will be the answer here. So this is false. So I think to rewrite this, I think we would reverse them. Here's my answers, B or C. Okay, more calculations can be performed with data at the interval level than the nominal. This is right here, B. And you can see the answer right there. Okay. 6 here. Determine whether that's true or false. Data at the ratio level cannot be put in order. Now that's wrong. Ratio, you can do everything with it. All right, so that's false. So that's got to be A, B, or D. And you just read the statement here. Data at the ratio level can be ordered, although it's impossible to subtract value. That's wrong, because you can do subtraction and you can divide them. This is data at the ratio level can be ordered, although it's impossible to determine if one data value is a multiplier of the other. No, that's what ratio. The ratio is the only one that does that. I think we're at D, I guess. A ratio. Okay, a true statement is data at the ratio level can be placed in a meaningful order. That's it right there, D. Answer is D. Okay. All right, we'll skip over number 8 here. Determine whether a variable is qualitative or quantitative. Carrying capacities of flatbed trucks. Carrying capacities. So like how much can you put on a flatbed truck? All right, how much can you put on there? Well, that's quantitative. So this should be quantitative. Okay. Because it's something you can count. Because carrying capacities are numerical measures, not attributes or labels. So this would be numerical measures. So you can see the answers right there. Okay. What about number 9 here? Determine whether it's qualitative or quantitative. Wait time at the doctor's office. So that's definitely a number. So that's got to be quantitative. So it's going to be quantitative. Why? Because is it an attribute or level, or is it a numerical measure? What's a numerical measure? Okay, it's not this. Okay. Well, my pages are stuck. All right, let's go to 11 here. Determine whether the variable is qualitative or quantitative. Country of residence. All right, country of residence, there's no number involved in that. So that's got to be quantitative. I'm sorry, qualitative. Qualitative. It's got to be qualitative because there's no number concerned in that. All right, so the variable is quantitative. No, it's not this one. Not this one. All right, it's got to be one of these two here. Because the country is found by measuring or counting. No, we're not measuring or counting for. It's an attribute or characteristic. The answer is D. Okay, and you can see right there, the answer is D. Okay, what about this right here? All right, this is a good one. Determine whether the variable is qualitative or quantitative. Employee ID numbers. Your ID numbers. Okay, ID numbers, like let's say Sam is 102, Jerry is 106, and Steve is 110. That's their ID numbers. Okay? Well, now, does Steve, is he 8 more better than Sam? Is he 4 better than Jerry? Is Sam the low man on the totem pole because he's 102? No, these numbers really have no meaning as far as quantity. So really, this is a qualitative because it's an attribute or a level. Okay, has nothing to do with the numerical measurement at all. It's just a number assigned to somebody. Okay. Here you go, number 14. The years that a television show on a particular network won an award. All right, here's all the years that they won this particular award. Determine the level of measurement of this data set. Okay, what's the level of measurement here? Okay, so we've got these numbers here. Okay, now we can subtract them to see how long it is. Like right here, if I subtract those two, that was 3 years since they won it. right there. And here, if I subtract those, it's 12 years since they won that. So subtracting it does have a meaning. All right, so if you remember on the notes there, when you subtract, to be able to subtract something, that would be the interval level. All right, so looking at interval, data can be ordered and differences between the data are meaningful. All right, so now as far as ratio, we can't go up to ratio because there's no meaning as far as like division of these, like saying this is a multiplier of that one. So this is an interval. The answer is A. You can see right there, A. Okay, we'll do a few more of these and then, all right, here you go. Now I like this one. My dog's getting excited about food. The jersey number for players on a football team. Here's all the jersey numbers. Well, see, these numbers here have no meaning as far as value. Because like right here, is this guy here 7 better than that one? Is he 7 better than him? Is this guy 1 better than that guy? No. So these are just qualitative. These are just qualities about these players. And remember, qualities are just nominal or ordinal. Okay? So now, as far as being able to order them, you can put them in order as far as number, but that has really no meaning as far as what the players are. So I think this is just nominal. The data are categorized using numbers, but no mathematical computations can be made. Okay? It's not this one here. They can be arranged in order. We really can't, well, we can put these in number order, but that doesn't really mean anything. That's just a way to put them in order, and it's not really meaningful to do that. 16 right here. The list of books that your friend read for school the past 5 months. Here's the books they read. Okay, identify the level of measurement here. Well, we're listing these books, and there's no numbers involved at all. So that tells me right there it's got to be qualitative. Okay, it's got to be qualitative, which means it's either nominal or ordinal, because it's the only two that are qualitative. Okay, now we can't really put these in order, so I think this is just nominal. That's what we're looking at, nominal. And yep, that's right, nominal. Okay. Let's look at this 17 here. The graph at the right shows the number of cities with certain average annual rainfall amounts. Identify the level or measurement of the data listed on the horizontal and vertical axis. Okay. Now, when you have these right here, I have looked at this already. I noticed identify the level of measurement on the horizontal axis. We're looking at these, the number of cities, and that would be ratio, because I guess you can divide those. See, like here's it tells you numbers. You can divide to say that, you know, this is twice as much as that or something. Identify the level of measurement on the vertical axis. We're talking about the annual rainfall, and those you can subtract them, see how much one's more than another, or you can divide them to see, like this one. See, if you look at this one here, B, it looks like it's double what D is. So this would be ratio also. Both these are ratio. You can see the answer right there. Okay. A couple more we'll do here. Right here, number 20. The following appear on a physician's intake form. Identify the level of measurement of the data. All right, so we got weight, we got happiness level, family history of illness, and the year of birth. So if you look at A, what's the level of measurement for weight? All right, so if you're going to weigh somebody, is that going to be, now look how they're not in order, but it's NOIR. It's nominal, ordinal, interval, ratio. And the further down you go, the more computations you can do. Okay, well, if you have weight, you could say that one person is twice as heavy as another person. So this would be ratio. Okay, you can say, hey, this person's 50 pounds more than that person. You can subtract, which makes it interval, but you can divide them to see that someone weighs twice as much as a person, so that's ratio. What about the happiness level? Okay, this right here, I believe, is going to be interval because you could put them in order. You can order them, and you could subtract them. You can say this person's a 7, this one's a 4, so you subtract those. He's 3 more than that one. But as far as like dividing them, you can't say that this person's twice as happy as that person. So I think this would just be interval. And also, too, if 0, that's one way to tell about this inherent 0. If someone puts 0, does that mean they're like totally unhappy, not happy at all? So I don't think that really means 0. What's the level of measurement for family history of illness? Family history, I think that's just going to be nominal because like what's their history involved? There's no way to subtract them. And you probably can't put them in order like, well, hey, we had this and then this and that's more important than this. And so I think nominal is all you can do on that one. And then the year of birth, I think I messed up on this one. I think this one is ordinal. You could put them in order, but I really don't think you can subtract them on that one. So let's go back to that one. I think that's just ordinal. On this one, the year of birth, because this one here is interval. I think there's one of each kind. This is interval because you could say this person's 3 years older than that person. So this would be interval. Okay. All right, now let's go to this last. This is the last question on here. What is an inherent 0? All right, an inherent 0 right here is A 0 that implies none, that there is none. Okay, then it says here, select 3 examples of data that have inherent zeros. All right, so 0 means there's none. Okay, so if you look at this one here, this one is not inherent 0. The student's level of happiness, if you put 0, that does not mean that you're totally unhappy, that there's no happiness at all. So this is not inherent 0. Average monthly precipitation in inches. How much rain you have. If it's 0, that means you've had no rain. So this one is. So this one's one right here. Temperature in degrees in Fahrenheit. All right, temperature does not have an inherent 0. When you have 0 degrees, that does not mean that there's no heat at all. There is some heat. In fact, it even goes negative. So IQ scores of a high school class, that one's not. Average age of somebody, 0 means there's no age, so this one is. And then the maximum wind speed during a hurricane, that one is. If you have no wind speed, if it's 0, that means there's no wind at all. So these would be your 3 answers here for inherent zeros. Now, which ones are not inherent zeros? Well, the ones I put not. So temperature is not an inherent 0. Average monthly precipitation, students' level of happiness, and the IQ scores. These are not. Okay. Anyway, that's our data classification. You try those. If you have any help, let me know. I'll try to help you all I can. And that's all for today. If you have any questions, just give me a buzz. All right. Have a good rest of the day.